Good morning, everyone. I hope everything is okay. I have seen during the talk of Michael that there is already some questions. Thank you for asking them. We will just have some time after the presentation to answer all of them. So do not hesitate to ask questions on the chat, and we will spend some time in looking at it. During my talk now, I will mainly focus on the tools that have been developed within this project. So I have just some slides, and I will spend also some time on showing and typing code to write to show you how to use the toolbox. First of all, what are the objectives of the toolbox? As Michael said before, the netcdf files are very heavy, and for some of you or for a lot of partners, they are interested in obtaining time series at a specific location, which is not very easy to obtain as the way the data is outputted from WaveWatch. So the idea is to provide an as easy as possible and as quick as possible access to the datasets through, as Michael said, a specific web portal, and also with Python tools that relies on a time series database, which is called Cassandra, which is an open source solution, which allows to give access to time series in a very easy manner. And so this is for the data access, but we also want to provide developers with some support tools for the analysis of this data. So we have 4 main points that we want to address with this toolbox. So first of all is to compute global statistics with descriptive statistics. We also have some tools for resource assessment and for modeling of extreme values. We also have a module for producible assessment to assess what a specific device could produce in a specific location. And we also have a tool for operation and maintenance. So I've tried to summarize everything that is available in this toolbox. So first of all, we have an option or a possibility to retrieve the data for a given node, for a given time period, and for the list of parameters. And we also have the data is included in the toolbox to run some examples. So I said before, the functionalities can be separated into 4 different modules. So the first one is resource assessment, which allows to do some univariate statistics, bivariate statistics, such as scatter diagrams, histograms, and 2D plots, and also some distribution fitting. So for example, we have a module to fit variable data to 3-parameter variable data to the HS time series, which is a kind of classical for resource assessment. We also have a module on extreme value modeling. So we have access via a Python package to the classical models in 1D, namely the BlockMax and the POT approach. And also we developed the laboratory models for joint distributions. So for example, relying on copula or in conditional extremes in 2 and 3D. And we also give the opportunity to compute environmental contours in 2 and 3D, which is a state-of-the-art method for extreme value modeling in more than 1 dimension. We also have a tool for operation and maintenance, which can be model-based. So we'll give some details on this approach later on, but it's based from the Equimap project, which gives some model-based estimation of the waiting time and operational time. And we also have a module to compute the empirical the window from the time series, and also the waiting time and operational windows. And we have lastly, we have a module to estimate what the energies that could be produced by a classical wave energy converter device with an optimization from the power takeoff at each time step. So this work has been presented at UTech also by INOC and Central Nantes. So this method is implemented in this toolbox. I will give some example after. So as Michael said earlier, the main access point of one of the access point of this toolbox is to go to resourcecode.ifremer.fr. I will show you the website. So we have some example here to some showcase of the tools. So there is two different type of tools that we'll show later on. There are the static tools that can be viewed on mviewer.org. So these are just kind of a simple example that are not interactive, but give example of what is inside the toolbox and how the toolbox can be used to fit your needs. And we have some more advanced tools which are interactive that can be run on Binder, on mybinder.org. And I will show you, but when you click on these the links here, you can have access either to the source code of the application and also to an example of the use of these tools. All these tools are based on a toolbox that have been developed within the project, which is called the Resource Code Toolbox. It's open source, it's based on Python, and it's already available in PyP on the following link that is written here, pyp.org. And it's Senegate is as easy as going to pip install resource code. So it's very easy, and you can have access on your own computer. I will show you how it can be done. Along with this toolbox, we have the documentation associated to this toolbox. I will go into more details following, but I wanted to show the slide so that you can have the links to the toolbox. I will show you how to access it, but everything is documented. I will not go into details here on all the functionalities of this toolbox, but everything almost is documented. So I will try to do a live demonstration of this toolbox. I hope it will work smoothly. So, for example, here it's just a command line interface. I am on a blank folder, and I will just create a virtual environment on which I will install everything. So I can just type in a few commands here to activate this environment. And then, as said before, you can just install this pip install the resource code toolbox, so that it is downloaded directly from these from PyP and then installed on the computer. So before going into the details in it, I just want to show you the website, how it is constructed, and how you can go through this website. So as Michael said, you have the Explorer tool here, when you can see all the locations. By default, we only show 5,000 nodes because to keep some performances correct. So here you can zoom in on any location you want. So for example, here next to West, you can see in more detail the cost and the nodes. So I said before, the nodes are not all the nodes are shown. So here you can refresh depending on the zoom you select to print in all the nodes within the area. So here in blue, you have the nodes where the parameters are available, and you can also have the location where the 2D spectra are available. So it's on the cursor grid, but on this map you can see all the locations. You can also type in here your a point you want to look at. So for example, if you know some latitude, some coordinates, you can just type in, and it will select the closest node from the wanted location. And as Michael said, the Toolbox is the ANCAS database is covering 27 years, so you can also want to select some subset of the data. So you have a calendar which allows to select a specific time period you want for your data. And here you can select, we have a few statistics that are computed on the whole database to color the nodes. So for example, you can select the wave energy, the current speed, the cyclometric wave height, peak period, wind speed, and you have different statistics. For example, if you want to just to color the point according to the max HS, you can select this value, and you can just have a look at how the data looks at. So for example, if you want to select a specific location here in the Bay of Audion, sorry, you can select a specific node, and then once the node is selected, you can have access to different different notebooks, different descriptive tools that are run automatically on the data selected. So as you can see here in the URL, you have a point ID that indicates which point is selected. And when you select also a time period, this time period will be added in the URL, meaning that you can have access directly to this to the selected point and the selected duration, depending on the inputs. Sorry. It was working a few minutes ago, so I think. Oh my. Okay. So here you have an example of the time series of the different tools that can be used. So for example, when you click on descriptive statistics, then behind the hood, the package is loaded. The data is downloaded from the Cassandra database, and then the computations are done live on this data selected. So it might take some time depending on the load of the server, but it works very good. So for example, here you have a sample of 10 rows out of the whole database. So here the tool is static, so it cannot be changed directly by the user, but it gives access to different statistics such as the mean value, standard deviation, min max values, and some quantiles for each of the selected variables here, and also histograms. We also have access to time series, bivariate statistics, and wind roses. I will not go into details of each of them now, but I will show how these tools are computed based on the toolbox. So it might take some time. Here it retrieves all the data from this from the Cassandra database, but it retrieves the data on the whole time period of the 27 years of data, 27 years of the ANCAS database. Okay, this time it's not working. I don't know why. It's the demo effect. But as said before, all these tools rely on the resource code toolbox that I have installed here. Yeah, mainly. Yeah, man. I think that people are everyone is trying to access the server, and maybe it was not designed to have some such loads. So I will go into more details about the tools that are available. So for example, here you have once behind the Explorer tab, you have a tool tab, which you have access to different tools that have been developed within the project. So for example, here, as said before, you have for now 3 static tools that are available, and a few dynamic tools that are going to be that can be used already and that are going to be developed in the next as the toolbox will be used by the partners. So for example, here, when you click on this, you have access to an example Python notebook that shows the commands that are used and some example of how the toolbox can be used. So if you want to go into more detail about what is available here, you have access also to the source of this document, which is all available on the GitLab, the resource code GitLab page. So everything now it is public. You can have access to the different the tools that have been developed. And if you want to, you can have access to the source code, and you can also clone this repository on your computer to have access to the data and to be able to run your own analysis on it. So to do so, we just need a few more packages that are installed. So for example, we need Jupyter Lab that is going to be installed now. And I will also show you. So everything is installed. And here I just type in the git clone command that allows to clone this repository. So here, if you click on the clone button, you can clone. You have the link to clone directly this repository. So here the data is being downloaded on my computer. So as you can see here, we have the document that is being downloaded, and then running Jupyter Notebook on this document. You're going to run. You're going to have access to this notebook on your own computer that allows to run the code on your computer and to modify it as you want. So first of all, here I show some helpers. So for example, you have the grid field. It's the node number here, the coordinates, longitude, latitude, the corresponding depth, the point, and also the drain size at this location. You also have access to the grid of the spec where the full 2D spectra data is available. It's a grid spec function. We give access to, again, the coordinates, the name of this point, the depth, and the D50. As if you know the coordinates you want to look at, you can just type in, use the get closest point function, which in turns returns the selected node. So here I just changed to print selected node. So selected node is this node number, and you have the distance to the requested location in meters. I also type in some code just to have some map. So here in this in the toolbox we have the, as said before, the grid field, which is a ensemble of nodes, of blue nodes, which are the nodes location. The orange node, the orange points are the spectral grid nodes. And you can also print the coastline that is used in this INCAS data with get coastline, and the islands to have a nice map. Yeah. You can just type get islands to be sure what's going on here. And then I plot here, so you see the map, and here in red, it is a point that has been selected to conduct this analysis. And of course, here, because you are on a live Jupyter Notebook, you can change as you want the location of this point. You can also print the bathymetry. So here is an example of the bathymetry next to the selected location here. And you can continue here to show how to extract the data from the Cassandra database. So for example, here you use the method that is called get data frame from URL. So you just type in the URL that is taken from the website previously. So you have the resource code.ifremer.fr/ explore, the point ID, and then the start date time and the end date time. So if you do not specify these quantities, then the whole database is retrieved at this location. As we can see here, we retrieve some of the variables available. So the HS, the UNV wing component, the T02, FP, peak frequency. We also ask for TP, the peak period, peak direction, and wave energy. We have a small function to convert between the between the zonal and regional component to intensity and direction. So it's what I show here. And then when you do data.describe, it is a pandas method. So data is a pandas data frame that allows that have all the variables. And here you can have a small description of the wanted variables. Here I show an example also to compute the histograms. So the 6 histograms of variables that we want to show here. I have some code also to compute the monthly histograms, the monthly statistics, which can be of interest when you look at your data. So here it's called a violin plot. I use the Seaborn to do so, which is a very elegant plot. It shows both the variability and the histograms. Well, it is the histograms during each month at this location. So you see the seasonal variation and also the different distributions according the year. I have an example here to show you how you can plot the data. Well, it's using Plotly, which is a very convenient tool. It gives access to the whole time series of the data. So here you have the data from the beginning to the end of the Uncast, and you can zoom in to show to see specific events, and the different plots are zoomed in accordingly to the selected period. So if you want to select a specific time period here to show the specific event, you can see this event and how the different variables are related to this event. And of course, it can be modified to fill in your needs. I show also bivariate statistics, so it show how the parameters are related one to another. And last but not least, here I just want to show an example of how you can compute wind and wave roses. So with the Python package called WindRose that is imported at the beginning of this notebook, and then that allows to show how the data is varying across direction. So it's one of the examples of the tools that is available here. And as said before, we have an ensemble of tools that can be used. I just want to give a look to the weather window tool. So as I said before, the dynamical tools are applications that are convenient to use, but the code is a bit more complicated. So the source code is maybe not very useful to the users. So here I will show how you can download it. So as before, you can just git clone the tool you want. And then using Jupyter Flex, it's Jupyter Flex applications. Then you can have access to the notebook, the application, web application that is being that is developed. So as said before here, one way to access to ZETA is to specify the location here. So let's say you want to have access to this specific node. You copy this URL. You can copy it here, and then the model is fed to the data. So what kind of model is used here? So if you have some question, you can go on to the website, and you have a link here to the documentation of the toolbox. So you have access to documentation to install the library, etc. So here we have estimate of weather window. So it's documented that you can estimate probability of occurrence and expected mean number of events for a given target HS you do not want to access for a given duration. So it's a model-based procedures that have been developed within the EQMAP project that has been implemented here for ease of use. So you have monthly statistics. So what is done here is the available 3 parameter is fitted to the data, and then from this model you can compute some figures. So for example, here I show the mean window length. So if you want to not exceed 4 meters, then the mean duration of the window below 4 meters it's 50 hours during the month of January. And here you can select different months at this location. So for example, if again you want to not exceed 4 meters significant wave height, then this condition is never met in July. So 4 meters is never exceeded in July, this location. And you have also more complicated graphs. So here, if you want to, if you need a weather window of 100 hours, if you have different constraints on the HS, then you can look at the probability of occurrence to have such windows. So for example, you have a probability of 0.3 to have 100 hours window duration in July that do not exceed 3 meters. So these kind of tools can be very useful for to better understand how we can access to a specific location and how we can manage to have some operations at this location. So as said before, these tools here runs on my computer. So maybe not everyone wants to download the toolbox or wants to clone the repository, or not everyone can do it. So here, when you click on the tool, when you click on the play button, you are redirected to minebinder.org, which allows to run the tool. And it seems that MyBinder is not available for now, so it's I haven't tried it this morning, but MyBinder seems to be unavailable now, so I can assure you, but it will run the same way. So you have a web page when you can play on with this application without installing anything on your computer. So I said before, we have here a link to the documentation. So you have more examples. So how to install the library, how to query the data. You have examples to get the embedded data, so the closest point, the closest station, things like that. So everything is documented. So we hope it will be very easy for the people to use. We have also some examples of written value modeling, extreme value modeling, and computer-written levels. So this documentation is going to be completed. And of course, here you have also access to to all the tools that have been developed. And here you have also explanations for reproducible assessment, for example. And as said before, the toolbox is available on PyPy. I will show you maybe the website. So on PyPy here, you can have the command I use to install the toolbox, and you have also a link to the home page where you can see the GitLab repository of the resource code package. So this tool will be maintained by a team from here with partners. So if ever you find the issues or you want some additional functionalities, do not hesitate to send an email, to send issues, and to give us some feedback about this about the use of the toolbox and the difficulties you can face. I hope it will be more clear now,